Seventh-day Adventist Higher Secondary School, Shanmughapuram. Good morning, children. I am science teacher. I feel very pleasure for teaching science through online, and also I am very happy because I am making you study during this quarantine period. Today's lesson is measurement. What is meant by measurement? Measurement is the compare known quantity with the unknown things. After this lesson, what are all the knowledge or objectives? That means learning objectives we are going to get. See, understand the fundamental and derived quantities and their units. Know the rules to be followed while expressing physical quantities in SI system, and get familiar with the usage of scientific notations. Know the characteristics of measuring instruments. Use vernier caliper and screw gauge for small measurements. Find the weight of an object using a spring balance. Know the importance of accurate measurements. These are all the learning objectives. Now, introductions. Measurement is the basis of all important scientific study. It plays an important role in our daily life also. While finding your height, buying milk for your family, timing the race completed by your friend, and so on, you need to make measurement. Measurements answers questions like how long, how heavy, and how fast. Measurement is about assigning a number to a characteristics of an object or event which can be compared with other objects or events. It is defined as the determination of size or magnitude of quantity. In this lesson, you will learn about units of measurements and the characteristics of measuring instruments. Children, see the downloaded PDF from Tamil Nadu textbook. It's very important. Then only you can understand the concept of measurement. The first topic of the lesson is physical quantities and units. Physical quantities. Physical quantity is a quantity that can be measured by instruments. The physical quantities can be classified into two. One is fundamental quantities and another is derived quantities. What is meant by fundamental quantities? Quantities which cannot be expressed in terms of any other physical quantities are called fundamental quantities. Example, length, mass, time, temperature, and etc. Quantities which can be expressed in terms of fundamental quantities are called derived quantities. Example, area, volume, and density, etc. Physical quantities have a numerical value and a unit of measurement. Say 3 kilogram. Suppose you are buying 3 kilograms of vegetables in a shop. Here 3 is the numerical value and kilogram is the unit. Let us study about units now. Units. What is meant by units? A unit is a standard quantity with which the unknown quantities are compared. That means comparing the known one with the unknown. It is defined as specific magnitude of a physical quantity that has been adopted by law or conventions. For example, feet is the unit for measuring length. That means 10 feet is equal to 10 times the definite predetermined length called feet. Children, listen here. We move on next page. That means in earlier different systems were used in different countries. Some of the unit system followed earlier are given the table 1.1. The table has there are three older units. See the table system, CG system, FPS system, MK system, length, mass, time. CG system means centimeter, gram, second. FE system means foot, pound, second. MK system means meter, kilogram, second. Children, see the page clearly and get knowledge. But at the end of the Second World War, there was a necessity to use worldwide system of measurement. What is that measurement? That is SI system, International System of Units. System of Units was developed and recommended by General Conference on Weights and Measurements at Paris in 1960 for international usage. The SI system of units. Second topic is SI system of units. What is that? The SI system of units is the modernized and improved form of the previous system of units. It is accepted and almost all the countries. It is based on the certain set of fundamental units from which derived units are obtained by proper combination. There are 7 fundamental units in the SI system of units. They are also known as base units and they are given in the table 1.2. This very important quantities, that means fundamental quantities, which is given the table 1.2. Children, see the table very clearly. You can understand the what is meant by fundamental quantities. The units used to measure the fundamental quantities are called fundamental quantities, and the units which are used to measure the derived quantities called derived quantities. See the table 1.2, which has 7 fundamental quantities: length, mass, time, temperature, electric current, luminous intensity, amount of substance, and also given unit and symbol. Student, study clearly and see the page in your book or download the book from Tamil Nadu textbook. You can understand the fundamental units. The next topic is fundamental units 1.3. What is given as mechanism under this topic? Length. What is mean by length? Length means very clearly given. What is mean by length? Length is the distance between the 2 points, or length is the extent of something between 2 points. The SI unit of length is meter. 1 meter is the distance travelled by light through vacuum in 1 by 29, 97, 92, 458 second. Now we'll move on the table. The table is derived table with the help of the table is derived quantities table with the help of fundamental quantities. See physical quantity expression unit. For example, area has length into breadth. Its unit is meter square. Volume has expression area into height. Its unit is meter power 3. Density mass by volume. Its unit is kilogram meter power minus 3. Velocity displacement by time taken. Its unit is meter per second inverse. Momentum mass into velocity kilogram meter second inverse. Acceleration velocity by time taken. Its unit is meter per second inverse. Like that, you have to prepare remaining derived physical quantities with help of this table. We move on. Next topic is, in order to measure very large distance, how can we measure the large distance between star and star, between planet and planet? So we'll use astronomical unit, light year and parsec. What is meant by astronomical unit? It is the mean distance of the center of the sun from the center of the earth. One astronomical unit, simply 1 AU, is equal to 1.496 10 power 11 meter. You can understand the astronomical unit by seeing this diagram. See, there is distance between center of sun to the center of earth. Now we move on light year. What is mean by light year? Important two more questions, children. Keep in your mind. Light year. It is the distance traveled by the light in 1 year in vacuum, and it is equal to 9.46 10 power 15 meter. Next is parsec. Parsec is the largest distance outside of the solar system. Parsec is the unit of distance used to measure the astronomical objects outside the solar system. One parsec is 3.26 a light year. Now we move on larger units, and also it is in the form of meter. Kilometer is in meter is 10 power 3 meter. Astronomical unit, it is in the meter is 1.496 10 power 11 meter. Already we seen these in the form of meter. Parsec 3.08 10 power 16 meter. Children, study well by using the PDF. Now move on. Next topic is now to measure small distances. We have seen so far larger distance. How can we measure small distance? It is the sub multiples of 10. That means how can we measure atom, molecules, and size of the nucleus by use of sub multiples of 10, and also quintal, metric ton also measured by multiples of 10. Smaller units in meter. Fermi 10 power minus 15 meter. Armstrong 10 power minus 10 meter. Nanometer 10 power minus 9 meter. Like that we have to study the smaller units with the help of this table. Now mass 1.3.2. Mass is the quantity of matter contained in a body. The SI unit of mass is kilogram. 1 kilogram is the mass of a particular international prototype cylinder made up of platinum iridium alloy, kept at the International Bureau of Weights and Measures Severus in France. The units gram and milligram are submultiples of 10, and quintal and metric tons are multiples of 10. Children, there is a numerical values along with unit is given. We can understand that what is meant by gram, milligram, and quintal and metric ton. Students, now new topic is atomic mass unit. Larger mass can be measured by kilogram. How can we measure mass of atom, mass of molecules? It is measured by a new system called atomic mass unit. Mass of a proton, neutron, and electron can be determined using atomic mass unit. 1 AMU equal to 1 by 12th of the mass of carbon 12 atom. Carbon atom divided into 12 times, and one of it taken as atomic mass unit. Listen clearly and get the knowledge of atomic mass unit. Now move on. More to know, that is mass of 1 milliliter of water is equal to 1 gram. Mass of 1 liter of water is equal to 1 kilogram. Mass of other liquids vary with their density. Now, what is meant by time? Time is the measure of duration of events and the intervals between them. The SI unit of time is second. 1 second is the time required for light to propagate 29 crores 97 lakhs 92,458 meters through vacuum. It's also defined as 1 by 86,400 part of a mean solar day. Larger units for measuring time are day, month, year, millennium, and etc. 1 millennium is equal to 3.16 10 power 9 seconds. Children, you can get the knowledge of time by keenly and repeatedly studying this topic. Now we move on. How can measure the temperature? The temperature is the measure of hardness of a hardness of a body or coolness of a body. The SI unit of temperature is Kelvin. 1 Kelvin is the fraction of 1 by 273.16 of the thermodynamic temperature of triple point of water. The temperature at which saturated water vapor, pure water, and melting ice are in equilibrium. 0 Kelvin is commonly known as absolute zero. The other units for measuring temperature are degrees Celsius and Fahrenheit. Now we move on next topic, that is unit prefixes. What is meant by unit prefixes? Unit prefixes are the symbols placed before the symbol of a unit to specify the order of magnitude of the quantity. They are useful to express very large and very small quantities. Kilo is the unit prefix in the unit kilometer. A unit prefix stands for a specific positive or negative power of 10. Some unit prefixes are given in the table. Now we'll move on the table. Where is the table now? Children, see the book or PDF. The table is now, see the table. The table has prefixes. That is, see, prefix of 10, prefix symbol. 10 power 15, peta, its symbol is P. 10 power 12, tera, its symbol is T. And 10 power 9, giga, G. 10 power 6, mega, its M. 10 power 3, kilo, K. 10 power 2, hecto, H. 10 power 1, deca, DA. 10 power minus 1, deci, D. 10 power minus 2, centi, C. 10 power minus 3, milli, M. 10 power minus 6, micro, mu. Children, see the chart or table clearly and take practices. Then only you can understand smaller and larger values of measurements. Now we move on. Next one is, see children, last very small quantities, 10 power minus 6 micro, mu 10 power minus 12, pico 10 power minus 15, femto, f. The physical quantities vary in different proportions, like from 10 power minus 15 meter being the diameter of nucleus to 10 power 26 meter being the distance between two stars, and 9.11 10 power minus 31 kilogram being the mass of electron to 2.2 10 power 41 kilogram being the mass of Milky Way galaxy. Now we entered a new topic, very important topic. The scientist assigned a rule for measuring the or to study the SI units and their symbols. The first rule is the units named after the scientist are not written with a capital initial letter. Example, Newton, we start small letter. Henry, start with small letter. Ampere, small letter. And what small letter? Second point, the symbol of the units named after the scientist should be written by initial capital letter. Example, N for Newton, H for Henry, A for Ampere, W for Watt. Symbol means we should use capital letter. Name means we should use small letters. These are the difference between point 1 and 2. We move on. Third point, small letters are used as a symbol for units not derived from a proper noun. Example, meter for M for meter and kg for kilogram. Fourth point, no full stop or other punctuation marks should be used within or at end of the, children see the table, end of symbols. Example, 50 meter, not as 50 meter along with full stop. The fifth point is the symbol of units are not expressed in plural form. Example, 10 kilogram, not as 10 kilograms. And sixth point, when temperature is expressed in Kelvin, the degree sign is omitted. Example 283 Kelvin, not as 283 degree Kelvin. It is expressed in Celsius scale, degree sign should be included. Example 100 degree Celsius, not as 100 degree 100 C, 108 degree Fahrenheit, not as 108 Fahrenheit. Now, seventh point is use of solidus, that means slash, is recommended for indicating the or indicating a division of one unit symbol by another unit symbol. Not more than one solidus is used. Example, meter second inverse or meter slash s. Joule by kilogram by mole should be joule, Kelvin inverse, mole inverse. Eighth point, the number and the unit should be separated by a space. Example, 15 kilogram meter second inverse, not as 15 kilo kgms inverse. Accepted, the ninth rule is accepted symbols alone should be used. Example, ampere should not be written amp and second should not be written as sec. The 10th rule is numerical values of physical quantities should be written in the form of scientific notation, not in the full form of numerical value. For example, the density of mercury be written as 1.6 10 power 14 kilogram meter minus 3, not as 13,600 kilogram meter power minus 3. Children, that is rules and convention is very important topic. So study well, take practices many time, use the quarantine period very usefully. Students, question will be sent along with this link. Complete it. Thank you.